All right. Well, welcome to the jungle. All right. So we do, Jeremy. I'm very, very impressed because you did actually identify the computer correctly. That is exactly what it is. So this is the 64 core. I didn't. That chip might be bigger, but it might be the faster megahertz later version. But this is 64 core chip is in here, 128 threads. And that's basically like having 64 computers in one place, which is nice, and I'll explain why later. Then we have 256 gigabytes of RAM, and then we have which you can do a lot more nowadays, but this seems to be fine. Here's that 4090 RTX NVIDIA GPU that is there. Why didn't I buy two? Well, I didn't buy two. The motherboard was going to be bigger, but I was stuck with this little guy here because the previous motherboard sort of, the one that originally was going to do it, was not installed correctly, and I kind of broke it. So I was in a pinch. I had to get this thing done. Darn it. Well, that motherboard, Jeremy, that you pointed out, yeah, I could use that right now. So then this was this is water cooling, and then this GPU is also water cooled, which is kind of cool. Then in here we have all our RAID setup, which is 4 NVMe M.2s, 4 terabytes each, and then we have our scratch discs in here, which are speedier. So these are those chips that he was putting in on the video. Those 960s are primo, and so we got a bunch of those in here. They write at 7,500. Bits per second, I think, maybe even faster, but that's what you use your scratch disc for. But here, for everything that you can't really lose, you have RAID here at a pretty high level where it's keeping itself duplicated. The drives fill up fast despite all that terabytes. There are more chips actually, more memory chips actually built into the computer itself. So yeah, and this is the operating system right there. So stays pretty cool. This open case system is pretty fun. There's a 64. But there's one thing so also this is the same 1600. So I don't know if it's the exact same brand, but it is a 1600 watt power supply. Let's see who makes that. That's 1600. This one goes up to 11. So this is a 1600 watt power supply, and then we have an extra 1200 watt power supply here on top of eGPU optical Optolink thing, which doesn't work with this computer, unfortunately. So I had to find that out the hard way. And then I know it's Petey, but it wasn't quite. Where are the skateboard trucks on that piece on that box? Because these boxes get heavy, and men get old, and so they think of stuff like this. My grandfather did this, probably. That's the kind of thing. But the roller skate trucks on here, skateboard trucks, work out awesome. So basically, what you just do is you pull it up by the handle, and then you can just move it along like a suitcase. And in fact, probably putting one of those slide up, slide down suitcase handles on there would be the thing to do. So thank you guys very much for that inspiration too. So we'll get that done. But yeah, and so what this basically can do with the magic behind this, you guys know what that is, right? So the magic behind all this is that the reason we're doing it is that we want to be able to run, we want to be able to code applications on site, specifically for the purpose of being able to pull the Ethernet cable out, disconnecting completely from the internet, so that all things can be, so all information can be managed here without putting it on someone else's cloud, which is really, really important. So right now, we're running what we can do is that we have LLM Studio here, and we have Qwen 32 billion instruct. That's possible with that 24 gigabyte RAM. It does work. I'll give you an example. So list all prime numbers between 1 and 1,000. So this is Qwen 32 billion running locally. Okay, and see how fast it can do this. It's always kind of crabby when I ask it to do this, but this is the thing I do to sort of get it started. Oh, I did not send that query in, so let's see how we do. And we are going to see if now that GPU, see the GPU is just popping. And so it went from utilization, right now we have 21 gigabytes of VRAM. Right now the utilization is popping up, as it should be, as it figures out what all, how to list all the prime numbers between 1 and 1,000. And it'll go ahead and do that. And that's kind of the pace that it loads. So this is not running on the internet. This is running completely locally here. Just everything is right on that. And that's how fast it's going. Now we are going to do some additions to it where we're going to get that CPU to actually where we take 40 CPU cores out of the 64, so the other first 24 run the system and everything like that, but then we can dedicate the 40 to 50 CPUs actually to doing nothing but working with the GPU to, you know, actually offloading some of the utilization on that GPU to down here where it's normally, maybe it'd be up here, but we can actually use MSI Afterburner and get this thing running it fast. For this project right here, I'll just quickly show you kind of like the goodies that we're working with. And for this project, we are using the following packages, you know, our core dependencies, and you can get an idea of all the stuff that we are using and stuff that we need to add actually. Pretty good, pretty neat setup there. I don't want to show up too much. GitHub is running on here. And so there's and then we have Docker Desktop, which is a container, program to test applications on. So we can put apps into, you know, portable little boxes, containers, so they can run the same way everywhere without breaking or saying, you know, it only works on my computer. So you know, when you create an application, you want your application to work on every computer. This is what it does. This creates the environment to make sure that that is actually going to happen. And that's the purpose of Docker, which actually runs a small mini LLM itself. And then so that's cursor working right now, the coding LLMs that we're using right now. So we have, for some reason, just experimenting. Normally I have 1 or 2 of these going, but we have about 8 agents running here at the same time. So using GPT 5.2 codex, you know, we can swap this out. Well, right now composers, this 2 combination for this particular project, this is the best combination for right now, as determined by performance benchmarks and stuff for specific tasks. So all that there, yes. Jeremy, very, very good eye. Yes, sir, that is exactly the same computer with a bigger motherboard, but it doesn't have the fucking trucks. Good job.